Hello guys, welcome to this new video about mesh analysis method. We have completed Kirchhoff's laws. Now we are going to understand what is mesh analysis and how to apply the mesh analysis method. Using the mesh analysis allows us to have the unknown current in the electric network. Mesh analysis is also known as loop analysis or the mesh current method. First, we need to understand what is a mesh. It's a loop which doesn't contain any inner loop. When we have a loop don't contain a loop inside, then we call the loop a mesh. We go now to steps required to perform the mesh analysis. We start with the step number 1 is to identify the total number of mesh. We go to step number 2 is to assign the mesh currents I1, I2 until In to the n meshes. Let's move to third step, applying Kirchhoff's voltage law KVL to each of n meshes. And finally, to solve the resulting n equations to get the mesh currents. Before we apply those steps, there are a few important points you need to know. The first one is the mesh analysis method is applicable only for a planar networks. This, for example, is not is non-planar networks. Why? Because we see this branch cut the other branch. Non-planar because we don't have the whole network in one plane. This is, for example, is a planar network of the first network. We can see here there is no branch cut the other branch, and the whole network is in one plane. We go now to note 2, the direction of mesh currents. The direction of the mesh currents is arbitrary, clockwise or counterclockwise, and does not affect the validity of the solution. We go now to note number 3 is number of equations required to solve an electrical network using mesh analysis. We have E is equal to M is equal to B minus N minus 1, where E is the number of equations, M is the number of meshes, and B is the number of branches, and finally N is the number of nodes. Let's go now to an example to learn how to apply the mesh analysis method. The question is to find the dissipated power in the 4 ohm resistor using mesh analysis method. Let's start with the step number 1 is to identify the total number of the meshes. We know that E is equal to M is equal to B minus N minus 1. We obtain finally the number of meshes is equal to 2 meshes. We go now to step number 2 is to assign the mesh currents. This can be done arbitrarily. This is mesh current 1 and this is mesh current 2, and I choose both direction is the clockwise direction. After we finish step number 2, we go to step number 3 is to apply Kirchhoff's voltage law KVL to each mesh. Let's start with mesh number 1. We have here negative 5 plus 2 I1 plus 2. We see here that I1 minus I2 is equal to 0. That means negative 5 plus 4I1 minus 2I2 is equal to 0. Finally, we go now to mesh number 2. We have 2I2 minus I1 plus 4I2 is equal to 0. That means 6I2 minus 2I1 is equal to to 0. After we finish applying Kirchhoff's voltage law KVL to each mesh, we go to step number 1. Number 4 is to solve the resulting equations to get the mesh currents. If we do equation 1 plus 2 multiplied by equation 2, we have negative 5 plus 10i2 is equal to 0. Finally, we have I2 is equal to 5 over 10, 0.5 amps. We go back now to equation 2. We already found I2. Then we have I1 is equal to 3 times I2. We obtain I1 equal to 1.5 amps.